Okay. Prove the following. Okay. 205. So we know for all epsilon 1 greater than 0, there exists a delta 1 such that delta 1 greater than 0, such that if x minus a is less than delta 1, then that means f of x minus L is less than epsilon 1. And also for all epsilon 2 greater than 0, there exists delta 2 greater than 0 such that x minus a is less than delta 2. Then that means gx minus m less than epsilon 2. And we need to show this. So we need for all epsilon greater than 0, there exists a delta greater than 0 such that x minus a is less than delta. Then f of x plus g of x minus L minus m is less than epsilon. Let's try and prove that. I think what I would have to do is split this up into fx minus L plus gx minus m less than epsilon. Okay, so we know that fx minus L is less than epsilon 1 and fx minus m is less than epsilon 2. So then that means if I add them together, perhaps fx minus L plus fx minus m is less than epsilon 1 plus epsilon 2. And then I can use the triangular inequality. Fx minus L plus fx minus m is less than epsilon 1 plus epsilon 2. But this is as long as x minus a is less than delta 1 and x minus a is less than delta 2. So it would seem to me that all we have to do is say there does exist a delta which would equal the minimum of delta 1 and or of delta 2. So yeah, and we can split the epsilon evenly. So what we could say then is, given an epsilon, let epsilon 1 equal epsilon over 2 and epsilon 2 equals epsilon over 2. Find the delta 1 and delta 2 for f and g. And that implies then that the delta we need is minimum of delta 1, delta 2. Okay, I'm pretty happy with that definition. We have found the delta. It's whichever is the smaller of the two deltas. and we can just split the epsilon equally and find the corresponding deltas and choose the smaller one. Yeah. I'm happy with that. Okay, let's have a look at 206 now. Okay. 206 limit. So that means then for all epsilon greater than 0, there exists a delta greater than 0 such that x minus a is less than delta, then absolute of CFX minus CL is less than epsilon. Okay, well, that's what we need to show using the previous definition. So, yeah. If C equals 0, we are done. I think actually I'll make it a little bit clearer. So just go back to the original premise. We know this. Now, we need to show what I just had a moment ago. We need to show that CFX minus CL is less than epsilon. So there's two cases. Case 1, C equals 0. Then that means we have 0 less than epsilon, so we're done. Case 2, C does not equal 0. So that means we'll have absolute of C times absolute of Fx minus L less than epsilon. So that means Fx minus L less than epsilon over absolute of C. Okay, that's okay. So yes, there does exist a delta such that Fx minus L will be less than epsilon over C when x minus a is less than delta. Just use the delta from Fx minus L less than epsilon form, but take the epsilon as epsilon divided by C. So I should maybe use different epsilons because it's looking like I'm saying the same thing. Like, e.g., if C equals 2 and epsilon equals 0.01, then use the delta for an epsilon equal to 0.005. And so CFX will have limit CL then. And I understand why they now wanted us to split it, because we can't divide by 0 here. So yes, there's this delta such that, okay, Just use the delta from fx minus delta, the original, the OG, but take epsilon instead as epsilon. Use the epsilon over c rather than your arbitrary epsilon. Okay, I could probably articulate that a little bit better, but that would be certainly the proof definitely clearly outlined. Last one looks tough. Okay. Now the product. Okay. So again, we'll have the epsilon